Hello, 10th grade. So, we are in a bit of a crazy situation right now. So I want to kind of talk to you about what's going to be happening this week so we can finish up our mechanics unit. As some of you are aware, I had a pretty rough school year last year in Venezuela, so I've done the virtual school thing and I've delayed tests, I've delayed assignments, and I have found that students are less successful. And you guys have worked so hard over the last 8.5 weeks to really master this mechanics unit. So I'm going to ask you to really amp up the effort this week and we're going to finish strong. We're going to skip the engineering challenge, unfortunately, and try and fit it in June, maybe after exams are over, as we kind of review for that, depending on what happens. And then we're going to just do the lab report, which was due last week. I'm giving you till Friday to do that, hand it in on Schoology. And we're going to be doing your test this week still. So the test will have two components, and I'll show you that first. One component will be done on Schoology. So on Schoology here, I have posted all these different review problems for you. I have the vocabulary list, which actually is not that bad for this unit, less than climate change. That's not about the vocabulary, as you know, it's about the calculation. So here's a whole bunch of practice problem things to work on and practice, as well as other practice problems are posted on Schoology with answers. Tomorrow, each class will be having our first kind of Zoom check-in lesson for half an hour to kind of check in about the process. If you have any questions, ask me. If you have any problems you want me to do a screencast lesson on, or some resources you need support with to prepare for your test. So what will happen is on Friday, everyone in both classes will log into Schoology and you will have a virtual test. So I can make a test on here with short answer calculations, that kind of thing, and I will do that with questions that are non-Googleable. Okay, so there's going to be questions you have to problem solve, and it will be on here, you'll complete it. And that's going to be half of your test score is through these virtual testing. It's going to be from 2:30 to 3:30 on Friday, at the end of the school day before the holiday, and then that will be half of your score. The other component of your test score is going to be from a virtual test you're going to complete with me. So I have shared this document with everybody, and what's going to happen, oh, here someone's already signed in. Riley's on it. So what you can do is you can sign up for a virtual test time. Now, to make this doable with our group of about 30 students, is going to be 5 sessions I'm going to run, and each session will have 6 students sign at the same time. All 6 students, you'll be given 2 or 3, depending how big they are, problems to do that will be different from the other classmates, and you will have to answer those problems while I watch. So you'll all be on your computers, you'll have your screen pointed, your camera pointed towards your pencil and paper, so I can see you working at your calculations. They'll be mostly calculations, and then you'll be expected to explain it to me orally how it works, and I'll be grading you on this. So there's 3 sessions on Thursday. Session 1 is at 8:30 to 9:30 in the morning. So 6 students from either class can sign up. Then session 2 is at 9:30 to 10:30 that morning as well on Thursday. Session 3 is also on Thursday in the afternoon, 2:30 to 3:30 p.m. So 6 students can sign up for that. And then on Friday, we have 2 more sessions, also in the morning. So 8:30 to 9:30 a.m. is session 4, and 9:30 to 10:30 a.m. is session 5. So you're going to sign up for 1 session only to do 2 or 3 practice test questions, not practice questions, but test questions that are going to be calculations, so I can see you doing them and so you can explain them to me. And then that afternoon on Friday, so at 10:30 we finish the last virtual session, and at 2:30 that afternoon you'll go into Schoology, you'll see your test is there, and you'll have an hour to complete that component of your test. Okay, so this week we have 3 classes. We'll be checking in on Monday, and then between Thursday and Friday, it's time to study for your test. Any last minute tweaks on your lab report that was due last week, you're welcome to do so. Feel free to message me, ask me questions. All that stuff is there. Something I was going to go through with you guys before you left was part of the engineering challenge, to talk about how engineers reduce impact during collisions. So if we take a look at this, everyone I'm sure has been aware throughout this unit, kind of thinking about the various ways that we can that cars and other vehicles are built to help us combat these various physical forces that act in our bodies in a car crash, different kinds of collisions. So we can now explain these using your knowledge of mechanics. So if you look here, some examples that you should know about are seatbelts, of course, airbags. So we have, here's a seatbelt, here's no seatbelt. We have an airbag here to cushion this person, bumpers in the back of your vehicle. The design of the passenger seat often is designed with these forces in mind, and a roll cage. You've ever been like on a dune buggy or one of those kind of racing vehicles, or maybe a Jeep? They have this metal frame around the exterior that if the car rolls over, turns over, it protects the passengers inside. So if you look at this picture here, the distance it would take the car to stop is only 1 foot. But if they're not wearing a seatbelt and the car crashes, the 160-pound driver is going to experience this huge force of 150 Gs or 24,000 pounds. Okay, and they're going to move really far forward because of inertia, right? So they're going to be moving forward quite a lot and probably going to hit their head in the windshield. Sometimes people go through the windshield depending on how fast the car is going, how big the impact is. And it's going to take them even more time so the person will fly free for about 0.2 feet. It's about an estimate. Depends on the mass of the person, a whole bunch of factors. But without the seatbelt to stop you, your inertia of the body will move forward and collide. So even with the seatbelt, you're still going to move forward, but it will keep you from going too far forward out the airbag, out the windshield. So the airbag will be deployed upon impact, and that means when you do move forward because of your inertia, you're going to hit this air cushion instead of your steering wheel, and less likely to have injury from that kind of collision. So this is the idea with inertia, momentum, impulse. These are all related here to how this works. So if we take a look here, we can kind of see how this fits into our equation. So seatbelts and airbags, they're going to help defeat the inertia acting on our bodies inside a vehicle. So it's going to prevent it from continuing the movement. So preventing them from continuing to move through the windshield onto the road. That's what we don't want to do, is to go through the windshield onto the road. That's very dangerous for everybody. So one way they do that is they're going to slow you down. By slowing you down, that's going to increase the amount of time. And we know if we increase the delta T, that's going to reduce the force. Okay, same impulse. If I increase delta T, I'm going to decrease the force. Okay, another way we can do this, if you look at a car, you have the bumpers we talked about earlier, and other parts of the car, they have what are called crumple zones. So crumple zones are there to increase delta T as well, and therefore reduce the average amount of force. So remember, delta T is the time from the first moment of collision until the movement stops. It's usually quite short. But if you can extend that by allowing the car to crumple more slowly, then the force will be less, acting on the vehicle, the people inside of it, all those kinds of things. The passenger seats, okay, and roll cages, those are made of materials that are meant to be sturdy enough that they can absorb the force acting on it, and the passenger itself won't be directly impacted by the force. So those are the last two little things I want to talk about in this unit before you did your egg designs. We are going to try and do those depending how the whole rest of the year progresses, probably after we finish our chemistry unit, probably after RAS exams in June, and we have a few days there, we'll do it then. So keep your ideas, write them down when they're still fresh so you can still do that challenge later on this year. Okay, so just to be clear with everybody, you have two tasks right now. You have your test, which is two parts. It has the part on Schoology Friday afternoon, and it has the part you're doing yourself. Okay, so Raleigh just signed up for Friday morning. So I'm going to approve that he can do that. And then you have your lab report, which was due last week, that I'm giving you until the rest of today to finish. Okay? If you have any questions, concerns, email me. I'll be scheduling a little Zoom check-in with everybody tomorrow at 9 a.m. for 10.1 and at 2:30 p.m. for 10.2. I'll post it on Schoology, download Zoom, get that sorted, and that way we can all check in tomorrow. Okay, it's going to be an interesting few weeks, but we can do it. Good luck, guys.